So hello all data science learners. Today we are again with another video in our data science series, and today we will be going to cover model evaluation. In model evaluation we will be covering all the matrices which we are required for modeling for evaluation. So let's move to the coding screen. So what is model evaluation? So model evaluation is the process that uses some matrices which helps us to analyze the performance of the model. There are many matrices like accuracy, precision, recall, F1 score, area under curve, confusion matrix, and mean squared error. So model evaluation is like the result of our test, what we have given. We can compare it to our college studies, that it is the result of the test. So what all the score we are getting, so we can predict that we have performed well or not. So in this also, if the accuracy is good, then the model is good. If it is not good, then model is not good, and further all. So let's see some evaluation metrics for classification task. First of all, we will see confusion matrix. So confusion matrix is normally a n cross n matrix when n is the number of target classes. So this is an example of confusion matrix in which these are if the actual outputs and this is the predicted output. So if the actual output is positive and the predicted output is also positive, then it is known as true positive. And if the actual output is positive but the predicted output is negative, so we are if we say that it is false negative. And if the actual output is negative but the model has predicted it as positive, so we say it as false positive. And if the actual output is negative and it is the predicted output is also negative, then we say it true negative. From this confusion matrix we calculate accuracy. So accuracy is the ratio of number of correct predictions to the normal number of predictions. So basically it is the probability of the model that the output will be correct, means it is true positive and true negative. So what formula? So true positive plus true negative, total number of true positive plus true negative divided by whole confusion matrix numbers, true positive, true negative, false positive, and false negative. Then another term comes precision. Precision is the ratio of true positive divided by total number of true positive and false positive. So it is basically focusing on positive predictions. So what are the accuracy and probability of positive predictions? And then comes a recall. So recall is the ratio of true positive and the sum of true positive and false negative. So it is basically focusing on number of correct positive samples. Then comes the F1 score. So F1 score is the harmonic mean of precision and recall. So it averages out the precision and recall and provides us a score from which we can compare our models. Then we also have evaluation metrics in regression task. So in regression task we have mean absolute error. It is the average of errors calculated. So y predicted, what is the predicted and what is the actual value divided by whole total number of samples taken. Then comes the mean squared error. In this the error is squared off and then it is divided by total number of samples taken, and again comes the root mean squared, where it is the root of the mean squared error. It is root mean squared. So in a mean squared error we will always get positive outputs, and we will compare it using different models. So let's have a practical knowledge of it. So we will be comparing some matrices for the C5.0 decision tree and random forest decision tree, which we have created which we have created in our previous video. So for this, calculating this in Python, we are importing sklearn.matrix, and we are from sklearn.matrix we are importing accuracy score, confusion matrix, F1 score, and recall score, and precision score. So here is the output. So what is the accuracy? It is 0.933 and 3 goes on, and this is the confusion matrix. So here in this model we were having three outputs. So this is a 3 cross 3 matrix, and then it is the F1 score, and this is recall score, and this is the precision score. So this was for a C 5.0 decision tree. Now we will compare it with the random forest algorithm. So in random forest algorithm we got that the accuracy is increased by 0.3 because here we are having accuracy of 0.96. So this random forest is a more accurate model. And then the confusion matrix has also changed because here I think 12 has come, and on the basis of confusion matrix the F1 score is calculated. So F1 score is also increased, and the recall score is also increased, and precision score is also increased. Here we can see that what was the 93 it was, and here for this it is 96. So it is improved. So we can, on this evaluation basis, we can say that random forest is more accurate and more predictable. So for the particular data set we can use random forest for a classification because it uses more than one decision tree and then predicts the output. And also for the regression we will be using it further in our regression videos to compare different models. So that's all for this video. Thank you.